Bismillahirrahmanirrahim. Assalamu alaikum. I welcome all my students of second year MBBS BDS classes to today's lecture regarding the movements of the small and large gut. Now, what are the movements of the small intestine, how they are taking place? Now, you all have to keep one thing in mind is that there is, although we are dividing the movements into the mixing type of movements and the propulsive type of movements, but they're always taking place with one another. They're helping one another. The main function is actually to mix the food, to mix whatever the semi-fluid semi-solid type of food that is coming from the stomach to that of the small gut, and how that is moving forward and what is taking place. So the two basic types, they are the mixing contractions, the propulsive contractions, and essentially all movements of the small gut is causing at least some degrees of both the mixing and propulsion. Mixing contractions, when a portion of the small intestine becomes distended with chyme, the stretching of intestinal wall elicits the local. So we can say that the stretch can be one of the major stimuli which is going to lead to formation of concentric contractions. Now, what are these contractions meant for? Well, these contractions, they are actually meant for to move the food forward, and this forward movement of food is taking place from small gut to large gut, and later on by anus, the feces is going out. And this is going to take place like at the rate of about zero point 0.5 to 2 centimeter per second. So this is the rate at which it is actually moving via small gut. The contractions, they are taking place at regular intervals and along the entire length of the gut, and is going to cause the segmentation of the small gut. They divide the intestine into spaced segments that have the appearance of a chain of sausages. See, they are regularly spaced, and they can be isolated, they can be irregularly spaced, they are weak regularly spaced. As one set of segmentation contractions relaxes, a new set often begins. But the contractions this time is going to occur at a new point other than that of the previous contraction. The segmentation contractions, they actually do chopping. What is this chopping? That is by contraction, the food contents, they're being broken down, they're being further, you can say, divided and subdivided into smaller pieces so that the enhancement of absorption is going to take place. So the chopping is taking place 2 to 3 times per minute in this way, and promoting the further progressive mixing of the food with secretions of the small intestine. The maximum frequency of the segmentation contractions in the small gut is determined by the frequency of electrical slow waves in the small intestine. The maximum frequency of the segmentation contractions in duodenum and proximal jejunum areas is about 12 per minute under extreme conditions of stimulation. In the terminal ileum, the maximum frequency is usually about 8 to 9 contractions per minute. So we have to keep this thing in mind that the contractions at the level of small gut is taking place at a much rapid pace rather than that in the large gut. The segmentation contractions, they become exceedingly weak when the excitatory activity of the enteric nervous system is blocked by the drug atropine. So you all should know that whatever thing is going to block the parasympathetic supply is going to block the activity, the contractions. The slow waves in the small muscle itself cause segmentation contractions, and these contractions are not effective without background excitation, mainly from the myenteric nerve plexus. See the different portions of the large gut: ascending colon, transverse colon, descending colon, sigmoid colon, and anus. Now we should be knowing about the propulsive movements, the peristalsis in the small gut. Chyme is propelled through the small gut by peristaltic waves, and these can occur in any part of the small intestine and they move toward the anus at a velocity of zero point 0.5 to 2 centimeter per second, which is faster in proximal intestine and is slower in the terminal intestine. They are normally weak and usually they die out after traveling only 3 to 5 centimeter area, rarely farther than 10 centimeters, so forward movement of the chyme is very slow. This means that 3 to 5 hours are required for passage of chyme from the pylorus to the ileocecal valve. Control of peristalsis by nervous and hormonal signals. Peristaltic activity of the small intestine is greatly increased after a meal. This is caused partly by the beginning entry of chyme into the duodenum, causing stretch of the duodenal wall. Peristaltic activity is increased by the so-called gastroenteric reflex, which is initiated by the distension of the stomach and conducted via myenteric plexus from stomach down to wall of small intestine. See how important this nerve plexus is, controlling the movements of the gut, controlling the secretion of the gut. It can enhance it, it can down it, or it can undermine its activity. In addition to nervous signals that may affect small intestinal peristalsis, there is some endocrinal aspect as well, which is affecting peristalsis. These are the hormones like gastrin, cholecystokinin, insulin, motilin, serotonin, and these are all going to enhance the intestinal motility and are secreted during the various phases of food processing. Saccharin and glucagon inhibit the small intestinal motility. On reaching the ileocecal valve, the chyme is sometimes blocked for several hours until the person eats another meal. At the time, a gastroileal reflex intensifies peristalsis in the ileum and forces the remaining chyme through the ileocecal valve into cecum of the large intestine. So, one important thing to know about is the propulsive effect of the segmentation movements. The segmentation movements, although lasting for only a few seconds' time, often also travel 1 centimeter or so in the anal direction, and during that time, it helps the propulsion, the moving of the food forward down the gut. We should be knowing about the peristaltic rush as well. The peristalsis in the small intestine is normally weak. Intense irritation of the intestinal mucosa, as it occurs in some severe cases of infectious diarrhea, can cause both powerful and rapid peristalsis and called the peristaltic rush, and is initiated partly by the nervous reflexes which involve the autonomic nervous system and brainstem and partly by intrinsic enhancement of the myenteric plexus reflexes within the gut wall. Movements caused by the muscularis mucosae and muscle fibers of the villi. The muscularis mucosae can cause short folds to appear in the intestinal mucosa. In addition, individual fibers from this muscle extend into the intestinal villi and cause them to contract intermittently. The mucosal folds increase the surface area exposed to chyme, thereby increasing absorption. Contractions of the villi shortening, elongating, and shortening again so that lymph flows freely from the central lacteals of the villi into lymphatic system. Functions of the ileocecal valve is to prevent the backflow of fecal contents into the colon from the colon into the small gut. Ileocecal valve itself protrudes into the lumen of the cecum and therefore is forcefully closed when excess of pressure builds up in the cecum and tries to push the cecal contents backward against the valve lips. So the valve usually can resist the reverse pressure of at least 50 to 60 centimeters of water. So this is the importance of the ileocecal valve. This is how the pressure of the cecum itself is going to keep this ileocecal valve closed so that the no backward movement of the motion of the um, cecal contents back into the uh, gut taking place. The valve can resist the pressure up to 50 to 60 centimeters of water. See, this important diagram is actually to show you how it is working. You can see the lips of the ileocecal sphincter, they do lie over there in the ileum. The pressure and the chemical irritation relaxes the sphincter and excites the peristalsis. The fluidity of the contents promotes the emptying, and the pressure or the chemical irritation in the cecum inhibits the peristalsis of ileum and excites the sphincter. So, the wall of the ileum for several centimeters immediately upstream from ileocecal valve have a thickened circular muscle called the ileocecal sphincter. This thickness is going to make it another, you can see, anatomical entity. Because of its thickened portion, it has more forcible contraction as one of its function. So this sphincter normally remains mildly constricted and slows emptying of ileal contents into the cecum. Now, immediately after a meal, a gastroileal reflex intensifies peristalsis in the ileum and emptying of ileal contents into the cecum proceeds. A resistance to emptying at the ileocecal valve prolongs the stay of chyme in the ileum, and thereby it is intensifying, it is facilitating, it is helping absorption. And normally only 1500 to 2000 ml of chyme empty into the cecum each day. So we should be knowing about this, that how this whole process is taking place, how the absorption is helping, how this one-way traffic is being maintained, and so the feedback control of the sphincter. The degree of contraction of the ileocecal sphincter and the intensity of peristalsis are controlled by the reflexes from the cecum. When the cecum is distended, the contraction of the ileocecal sphincter becomes intensified and the ileal peristalsis is inhibited, both of which greatly delays the emptying of additional chyme into cecum from the ileum. Any irritant in the cecum delays emptying, then a person has an inflamed appendix. The irritation of this vestigial remnant of cecum can cause such intense spasm of ileocecal sphincter and partial paralysis of ileum that these effects together block the emptying into the cecum. The reflexes from the cecum to ileocecal sphincter and ileum are mediated both by way of myenteric plexus in the gut. See the movement of colon, how it is taking place. This diagram is actually helping us to know about how the sphincter is working, how this connection between small gut, large gut is working, what things can intensify it, what things can decrease it, or so. So this is all. This is the last slide of today's lecture about the absorption of water and electrolytes from the chyme to form the solid feces taking place. Storage of fecal matter occurs until it can be expelled. The proximal half of colon is concerned with absorption and the distal half is with that of the storage. The movements still have characteristics similar to those of small gut and can be divided once again into mixing and propulsive movements. So this is all about the today's lecture, and stay tuned till we uh, meet in this lecture again. So till then, stay blessed and Allah Hafiz.